Welcome back to the Boring Science channel, where we explore the cosmos one gentle wonder at a time. Tonight, we're drifting towards something truly magnificent, something so vast and commanding that it quietly governs an entire neighborhood of space. We're talking about Jupiter, the giant of our solar system, a world so massive it almost became a star. I hope this journey helps you settle into that peaceful place between curiosity and rest. Though if you find yourself staying awake to ponder the sheer scale of things, well, at least you'll be marveling at one of the universe's most spectacular creations. Before we begin our slow orbit around this cosmic giant, I'd love to know where in the world you're listening from tonight. Are you tucked under blankets, watching city lights, or perhaps somewhere quiet where you can see Jupiter itself hanging like a bright jewel in the dark sky? Drop a comment and let me know what time it is in your corner of the world. If you enjoy these gentle explorations through space and science, I'd be grateful if you gave this video a like and tap that subscribe button. It helps other curious minds find their way to these peaceful cosmic journeys. And just a soft reminder before we drift into the depths of space, this video is for educational and relaxation purposes only, not intended as a substitute for professional astronomical advice or a cure for planetary homesickness. So settle in, let your thoughts expand like the universe itself, and let's begin this quiet voyage to understand just how massive Jupiter really is. When we say Jupiter is massive, we're not just talking about big in the way a mountain is big, or even big in the way the ocean is big. We're talking about a kind of bigness that stretches the imagination, that makes you pause and wonder how such enormity can exist in the same solar system as our small, cozy Earth. To begin understanding Jupiter's true scale, let's start with something wonderfully simple. If you were to hollow out Jupiter completely, like scooping out the inside of a cosmic pumpkin, you could fit more than 1/300 Earths inside it. Not 13, not 130, but more than 1,300 of our entire planet, nestled together in Jupiter's vast interior like marbles in a jar. But even that comparison feels abstract, doesn't it? Let's make it more tangible. Imagine Earth as a grape sitting quietly on your kitchen counter. In that same scale, Jupiter would be about the size of a basketball. Not a tennis ball, not a softball, but a full basketball, sitting there with such presence that it would dominate the entire room. This massive difference isn't just impressive, it's fundamentally important to how our solar system works. Jupiter's enormous mass, about 318 times that of Earth, gives it a gravitational pull so strong that it acts like a cosmic shepherd, herding asteroids and comets, protecting the inner planets from what could be catastrophic impacts. Think of Jupiter as the gentle giant of the solar system, using its massive gravitational embrace not to destroy, but to organize and protect. It's been doing this for billions of years, quietly maintaining order in our cosmic neighborhood while we've been down here on Earth, completely unaware of our massive guardian. But Jupiter's bigness goes beyond just its physical size. Its mass is so significant that it actually causes the Sun to wobble slightly as Jupiter orbits around it. Yes, you heard that right. Jupiter is so massive that instead of simply orbiting the Sun like a planet should, it actually causes our star to dance a gentle cosmic waltz, both bodies rotating around their shared center of mass. This center of mass, called the barycenter, lies just outside the Sun's surface. It's as if Jupiter is so substantial that even our mighty Sun has to acknowledge its presence and adjust accordingly. This gravitational relationship is so pronounced that astronomers use similar wobbles in distant stars to detect planets orbiting them, planets we call exoplanets. To put Jupiter's mass in perspective, it contains more than twice the mass of all the other planets in our solar system combined. Saturn, with its magnificent rings, Uranus with its sideways spin, Neptune in its distant blue majesty, Mars, the rusty wanderer, Venus shrouded in clouds, Mercury racing around the Sun, and our own precious Earth, all added together, still don't equal Jupiter's incredible bulk. This dominance isn't just a cosmic curiosity, It's a fundamental part of how our solar system formed and continues to function. When the solar system was young, Jupiter's massive gravity helped sweep up much of the leftover material from the Sun's formation, growing larger and larger until it became the behemoth we see today. But here's something beautifully paradoxical about Jupiter's size. Despite being so massive, despite containing more matter than all its planetary siblings combined, Jupiter is actually less dense than water. If you could find a bathtub large enough, Jupiter would float. This is because Jupiter is made primarily of hydrogen and helium, the lightest elements in the universe compressed into a ball of unimaginable proportions. Imagine that for a moment. This giant of the solar system, this gravitational powerhouse that shapes the orbits of countless smaller bodies, would bob gently on the surface of a cosmic ocean. It's a reminder that in space, size and density don't always go hand in hand, and that even the mightiest objects can surprise us with their delicate compositions. Jupiter's massive scale becomes even more remarkable when you consider its distance from us. Even though Jupiter is on average about 390 million miles away from Earth, it's still one of the brightest objects in our night sky. This brightness isn't because Jupiter produces its own light like a star, but because its enormous size reflects so much sunlight back toward us. When you see Jupiter twinkling in the evening sky, you're witnessing reflected sunlight that has traveled millions of miles from the Sun to Jupiter, bounced off its vast cloud tops, and then journeyed millions more miles to reach your eyes. That tiny point of light represents something so large that it defies easy comprehension. The ancient astronomers, watching Jupiter slowly wander across the sky, called it a wandering star. They had no idea they were observing a world so massive it could have been a star itself. In fact, if Jupiter had been born with just a bit more mass, perhaps 80 times more, it would have ignited nuclear fusion in its core and become a second sun in our solar system. Picture that for a moment. Instead of our familiar solar system with one sun and its family of planets, we might have lived in a binary star system, with Jupiter shining as a small red dwarf star. The night sky would never truly be dark, and life on Earth, if it could exist at all, would be fundamentally different. But Jupiter didn't quite make it to stardom. It remains what astronomers sometimes call a failed star, a massive ball of gas that came tantalizingly close to igniting but fell short of that crucial threshold. Instead, it became something perhaps more wonderful. A planet so large and influential that it shapes the very architecture of our solar system. Jupiter's massive presence affects not just the paths of asteroids and comets, but also the orbits of the other planets. Its gravitational influence helped determine where the asteroid belt formed, why Mars is smaller than it might otherwise have been, and how the outer planets settled into their current orbits. This gravitational choreography has been going on for over 4 billion years, a slow, patient dance of massive bodies responding to each other's presence across the vast emptiness of space. Jupiter leads this dance not through force or violence, but through the gentle, persistent pull of its enormous mass. The more we study Jupiter, the more we realize that its size isn't just a number or a curiosity. It's a fundamental feature that has shaped the entire history of our solar system. From the formation of the planets to the delivery of water to Earth, from the protection of our inner solar system to the timing of impacts that may have influenced the evolution of life, Jupiter's massive presence has been quietly writing the story of our cosmic home. And yet, for all its enormity, Jupiter remains beautifully accessible to us. You can step outside on any clear night when Jupiter is visible and see this giant with your own eyes. Through a small telescope, you can even see its 4 largest moons, the same ones that Galileo discovered over 400 years ago, tiny worlds dancing around their massive parent. Those moons, Io, Europa, Ganymede, and Callisto, are worlds in their own right. Ganymede, the largest of Jupiter's moons, is actually bigger than the planet Mercury. Europa may harbor an ocean beneath its icy surface, possibly containing more water than all of Earth's oceans combined. These are not just rocks orbiting Jupiter, they're complex worlds with their own stories, their own mysteries, all held in the gravitational embrace of their massive parent. The system of Jupiter and its moons is like a miniature solar system, a family of worlds bound together by gravity and synchronized in their orbital dance. Jupiter's massive gravity keeps these moons in line, prevents them from wandering off into space, and in some cases, kneads and flexes them with tidal forces that keep their interiors warm and possibly habitable. This is the power of Jupiter's mass, not just to dominate through size, but to create, to organize, to nurture entire systems of worlds. It's a reminder that in the cosmos, bigness isn't just about taking up space, it's about the capacity to influence, to shape, to create order from chaos. As we continue our gentle exploration of Jupiter's incredible scale, we'll discover how this massive world came to be, how it continues to grow even today, and why understanding its size helps us understand not just our own solar system, but solar systems throughout the galaxy. As we drift deeper into contemplating Jupiter's immense scale, let's pause to consider something that might surprise you. Jupiter isn't finished growing. Even now, as you listen to these words, this massive world is still slowly accumulating material from space, still adding to its already staggering bulk through a process so gradual it unfolds across cosmic time. Every day, Jupiter sweeps up cosmic debris, meteoroids, and dust particles with its powerful gravitational field. It's like a cosmic vacuum cleaner, constantly cleaning up the neighborhood while adding microscopic amounts to its own mass. These additions are tiny by Jupiter's standards, perhaps a few tons here and there, but over millions and billions of years, they add up. This ongoing accretion reminds us that planets aren't static objects frozen in time. They're dynamic, evolving worlds that continue to change, even if that change happens so slowly that entire human civilizations could rise and fall without noticing any difference in Jupiter's size. But to truly appreciate how Jupiter became so massive in the first place, we need to travel back in time, back to the very beginning of our solar system, when everything we know was nothing more than a swirling cloud of gas and dust floating in the darkness of space. Picture, if you will, a nebula, a vast stellar nursery where new worlds are born. About 4.5 billion years ago, something disturbed this peaceful cloud. Perhaps a nearby star exploded, sending shock waves rippling through space. This disturbance caused the cloud to begin collapsing under its own gravity, spinning faster and faster as it condensed like a figure skater pulling in their arms. At the center of this spinning disk, material began to accumulate, growing denser and hotter until it eventually ignited as our sun. But the story doesn't end there. The remaining material in the disk began to clump together, forming the building blocks of planets. And here's where Jupiter's story becomes truly remarkable. Jupiter formed in what astronomers call the frost line, that magical distance from the young sun where water could freeze into ice. This might not sound particularly significant, but it was absolutely crucial to Jupiter's eventual enormity. Beyond the frost line, there was not only rocky material to build planets from, but also vast amounts of water ice, and more importantly, frozen gases that would become the raw materials for a giant world. The early Jupiter started much like the inner planets, as a solid core of rock and ice. But this core, forming in the outer reaches of the solar system where material was more abundant, grew much larger than the cores of the inner planets. And here's where the magic happened. Once Jupiter's core reached a critical mass, somewhere between 10 and 20 times the mass of Earth, something extraordinary occurred. The core became massive enough to begin capturing gas directly from the surrounding nebula. Hydrogen and helium, the most abundant elements in the universe, began falling onto the growing planet like a cosmic snowfall that never ended. This process, called runaway gas accretion, transformed Jupiter from a large rocky world into the gas giant we know today. Imagine watching this transformation in time-lapse. First, a ball of rock and ice, growing slowly as it sweeps up debris. Then, suddenly, the pace quickens dramatically as the planet begins gulping down enormous quantities of gas. Within perhaps a few million years, Jupiter ballooned to nearly its current size, becoming a massive world that would dominate the outer solar system for billions of years to come. This rapid growth had profound consequences for the entire solar system. Jupiter's increasing mass began to sculpt the orbits of other forming planets. It may have prevented Mars from growing larger by gravitationally stirring up the asteroid belt, making it difficult for a larger planet to form there. It likely influenced the formation of the outer planets and helped determine the final architecture of our cosmic neighborhood. But Jupiter's influence extended even further. Some scientists believe that Jupiter's gravity helped deliver water to the inner solar system, including Earth. Comets and asteroids, pushed and pulled by Jupiter's massive gravitational field, may have carried the water that eventually filled our oceans and made life possible. It's a humbling thought, isn't it? That the water in your evening cup of tea, the water that makes up most of your body, may have been delivered to Earth through the gravitational influence of this distant giant. Jupiter's mass doesn't just shape orbits and capture moons, it may have helped create the very conditions that allowed us to exist. The scale of Jupiter's formation also tells us something profound about planetary formation in general. The process that created Jupiter isn't unique to our solar system. Astronomers have discovered thousands of exoplanets orbiting other stars, and many of these are gas giants similar to Jupiter, though some are even more massive. These discoveries have revealed that Jupiter-sized worlds are actually quite common in the universe. Some orbit much closer to their stars than Jupiter does to our Sun, creating hot Jupiters with surface temperatures that would melt metal. Others are even more massive than Jupiter, approaching the boundary between planet and brown dwarf star. But our Jupiter, with its particular mass and orbital distance, appears to be just right for creating a stable, life-friendly solar system. It's massive enough to protect the inner planets from too many catastrophic impacts, but not so massive that it disrupts their orbits. It's far enough from the Sun to allow the inner planets to form properly, but close enough to influence the overall structure of the solar system. This delicate balance makes Jupiter's mass not just impressive, but essential. Without a world of Jupiter's particular size in roughly Jupiter's particular orbit, our solar system might look very different. Earth might be a barren rock, or it might not exist at all. As we contemplate Jupiter's massive scale, it's worth remembering that size in space isn't just about impressive numbers or mind-bending comparisons. Size, especially Jupiter's size, is about influence, about the power to shape worlds and guide the evolution of entire planetary systems across billions of years. Jupiter's enormous mass creates what scientists call a gravitational well, a deep depression in the fabric of space and time. Other objects that venture too close find themselves trapped in this well, forced to orbit the giant planet. This is how Jupiter captured its extensive family of moons, over 80 of them discovered so far, each one telling its own story about the power of Jupiter's gravitational embrace. Some of these moons are tiny, irregular chunks of rock and ice, probably captured asteroids that wandered too close to Jupiter's gravitational influence. Others are large, spherical worlds with complex geology and, in some cases, the potential for life. The largest, Ganymede, is bigger than Mercury and has its own magnetic field. Europa's subsurface ocean may contain more than twice as much water as all of Earth's oceans combined. These moons exist because of Jupiter's mass. Without that enormous gravitational field, they would be wandering through space as independent worlds, if they existed at all. Instead, they've become part of Jupiter's extended family, locked in orbital dances that have persisted for billions of years. The rhythmic patterns of these orbital dances reveal something beautiful about Jupiter's gravitational influence. Many of Jupiter's moons are locked in what astronomers call orbital resonances, where their orbital periods are related by simple mathematical ratios. Io orbits Jupiter exactly twice for every orbit of Europa, and exactly 4 times for every orbit of Ganymede. This isn't coincidence. It's the result of Jupiter's massive gravity organizing its moon system into a cosmic clockwork of extraordinary precision. This gravitational choreography extends beyond Jupiter's immediate family. The planet's massive presence influences objects throughout the outer solar system, from the Trojan asteroids that share Jupiter's orbit to the Kuiper Belt objects in the far reaches of the solar system. Jupiter's gravity reaches across hundreds of millions of miles, a testament to the fundamental force that mass exerts on the geometry of space itself. Understanding Jupiter's mass also helps us appreciate the elegant physics that govern our universe. Einstein's theory of general relativity tells us that mass warps space and time, creating the phenomenon we experience as gravity. Jupiter, with its enormous mass, creates a significant warp in the fabric of space-time around it, a cosmic depression that influences everything in its vicinity. This warping of space-time isn't just theoretical physics, it's a reality that affects space missions to the outer solar system. Spacecraft traveling to Saturn, Uranus, or Neptune often use Jupiter's massive gravity to gain speed, a technique called a gravitational slingshot. The spacecraft falls into Jupiter's gravitational well, gains energy, and then escapes at higher velocity than it entered, using Jupiter's own orbital motion to boost its journey to the outer planets. These gravitational assists have allowed us to explore the outer reaches of our solar system with relatively modest rockets. Without Jupiter's massive presence to provide these velocity boosts, missions to the outer planets would require much larger, more expensive spacecraft if they were possible at all. In this way, Jupiter's mass continues to serve humanity, just as it has served our solar system for billions of years. It protects us from cosmic debris, it helped deliver the water that makes life possible, and now it helps us explore the cosmos beyond our small blue world. As we drift further into our exploration of Jupiter's incredible scale, we begin to see that this giant world is more than just an impressive collection of hydrogen and helium. It's a fundamental component of our cosmic home, a world whose very existence has shaped the story of our solar system and continues to influence that story today. Jupiter's massive scale becomes even more extraordinary when we consider how it moves through space. Despite its enormous size, Jupiter completes one rotation on its axis in just under 10 hours, making it the fastest spinning planet in our solar system. This rapid rotation creates a day on Jupiter that's less than half as long as an Earth day, a reminder that even the most massive objects in space can be surprisingly nimble. This swift spin has profound effects on Jupiter's shape and structure. The planet isn't perfectly round like a marble, but rather bulges at its equator due to the centrifugal force of its rotation. Jupiter is actually about 7% wider at its equator than from pole to pole, creating an oblate shape that would be quite noticeable if you could see the planet from the side. It's as if this cosmic giant is slightly flattened by its own energetic dance through space. The rapid rotation also drives Jupiter's magnificent atmospheric dynamics. Those beautiful bands of clouds that stripe the planet from pole to pole are the result of Jupiter's quick spin combined with its massive size. The planet's enormous bulk creates powerful convection currents as heat from the interior rises toward the surface, while the rapid rotation shapes these currents into the distinctive bands we see through telescopes. These atmospheric bands aren't just pretty patterns, they're rivers of gas flowing at tremendous speeds around the planet. Some of these jet streams reach velocities of over 400 miles per hour, creating winds that would make Earth's most powerful hurricanes seem like gentle breezes. The energy driving these winds comes from Jupiter's own internal heat, a reminder that this massive world is still cooling down from its violent formation billions of years ago. Speaking of internal heat, here's something that might surprise you. Jupiter actually radiates more energy into space than it receives from the Sun. This isn't because Jupiter is secretly a star, but because it's still slowly contracting under its own enormous gravity, converting gravitational potential energy into heat. Every year, Jupiter shrinks by about 2 centimeters as it continues to settle into its gravitational embrace with itself. This internal heat source means that Jupiter would glow faintly in infrared light even if the Sun disappeared tomorrow. The planet generates about twice as much heat as it receives from our star, making it a kind of warm beacon in the cold outer reaches of the solar system. This warmth helps drive the complex weather patterns we see in Jupiter's atmosphere and may contribute to keeping some of its moons geologically active. The Great Red Spot, that famous storm larger than Earth itself, is perhaps the most visible manifestation of Jupiter's massive energy. This hurricane-like system has been raging for at least 400 years, possibly much longer, sustained by the planet's internal heat and the energy of its rapid rotation. The fact that a storm can persist for centuries on Jupiter speaks to the incredible scale of the forces at work in the planet's atmosphere. To put the Great Red Spot in perspective, imagine a hurricane on Earth that was twice the diameter of our entire planet and had been spinning continuously since before your country was founded. That's the kind of weather system that Jupiter's massive scale can sustain, a storm so large and persistent that it has become one of the defining features of the giant planet. But Jupiter's atmospheric dynamics extend far beyond just the Great Red Spot. The planet is dotted with dozens of smaller storms, each one larger than the most powerful hurricanes Earth has ever seen. These storms appear as oval-shaped features in Jupiter's cloud bands, swirling vortices of gas that can persist for decades or even centuries before finally dissipating. The colors we see in Jupiter's atmosphere, those beautiful browns, reds, yellows, and whites, come from complex chemical reactions driven by the planet's internal heat and solar radiation. Compounds like ammonia, methane, and sulfur interact in Jupiter's atmosphere to create a palette of colors that would make any artist envious. The exact chemistry behind these colors is still being studied, but we know that Jupiter's massive scale allows for atmospheric processes that simply couldn't occur on smaller worlds. Jupiter's immense gravitational field also creates some unique phenomena that we don't see elsewhere in the solar system. The planet's magnetosphere, the region of space dominated by its magnetic field, is truly colossal. If we could see Jupiter's magnetosphere with our naked eyes, it would appear larger than the full moon in Earth's sky, even though Jupiter is hundreds of millions of miles away. This enormous magnetosphere is generated by Jupiter's rapid rotation and its metallic hydrogen core, a form of hydrogen that exists only under the extreme pressures found deep within the giant planet. The magnetic field traps charged particles from the solar wind, creating radiation belts around Jupiter that are thousands of times more intense than Earth's Van Allen belts. These radiation belts make Jupiter a dangerous place for spacecraft, requiring special shielding to protect sensitive electronics. The Juno mission, currently orbiting Jupiter, follows a highly elliptical orbit that minimizes its time in the most intense radiation zones, ducking in close to the planet for brief periods before retreating to safer distances. The interaction between Jupiter's massive magnetic field and its moons creates some spectacular phenomena. Io, the innermost of the 4 large moons, is constantly bombarded by radiation as it orbits through Jupiter's magnetic field. This radiation, combined with tidal heating from Jupiter's gravity, helps drive Io's incredible volcanic activity. The Moon has over 400 active volcanoes, more than any other world in the solar system. Europa too feels the influence of Jupiter's magnetic field. As this ice-covered moon orbits through the magnetic field lines, electrical currents are induced in its subsurface ocean. These currents create a secondary magnetic field that we can detect with spacecraft, providing strong evidence for the existence of Europa's hidden ocean beneath its frozen surface. Even Ganymede, the largest moon in the solar system, has its own magnetic field that interacts with Jupiter's much stronger one. This interaction creates auroras at Ganymede's poles, similar to the northern and southern lights on Earth, but powered by Jupiter's immense magnetic influence rather than our own planet's much weaker field. Jupiter's massive presence also affects the very fabric of space around it in ways that Einstein predicted, but that we've only recently been able to measure directly. The planet's enormous mass creates ripples in space-time that propagate outward at the speed of light, carrying information about Jupiter's motion and rotation to distant observers. These gravitational waves from Jupiter are incredibly weak by the time they reach Earth, far too small to detect with current technology, but in principle, they exist, a testament to the fundamental connection between mass, space, and time that governs our universe. Jupiter's immense bulk is literally broadcasting its presence to the cosmos through these subtle distortions in the fabric of reality itself. The study of Jupiter's mass and its effects has also revolutionized our understanding of how planetary systems form and evolve. Computer simulations of planetary formation show that the timing of Jupiter's growth was crucial to the development of our solar system as we know it. If Jupiter had formed earlier or grown larger, it might have migrated inward toward the Sun, potentially ejecting the inner planets from the solar system entirely. This scenario, known as planetary migration, has been observed in many other star systems, where large planets have indeed spiraled inward to orbit very close to their parent stars. These hot Jupiters, as they're called, may be failed solar systems, where the gravitational influence of a massive planet disrupted the formation of smaller, potentially habitable worlds. Our Jupiter, thankfully, appears to have formed at just the right time and grown to just the right size to stabilize rather than disrupt the inner solar system. Its massive presence helped clear the asteroid belt of most large objects while protecting Earth and its neighbors from excessive bombardment by comets and asteroids. This protective role continues today. Jupiter's powerful gravity deflects or captures many potentially dangerous objects before they can reach the inner solar system. While some impacts still occur, they would be far more frequent without Jupiter's massive gravitational shield. In a very real sense, Jupiter's enormous size helps keep Earth safe, allowing life to evolve and flourish over billions of years. The more we learn about Jupiter's mass and its consequences, the more we appreciate how finely tuned our solar system appears to be. A Jupiter that was significantly more or less massive might have created a very different cosmic neighborhood, one perhaps less hospitable to the emergence of life on Earth. This delicate balance reminds us that Jupiter's impressive size isn't just a curiosity or a record-breaking statistic. It's an integral part of the cosmic clockwork that has allowed our small blue world to remain stable and life-friendly for billions of years. Every time we look up at Jupiter in the night sky, we're seeing not just a massive planet, but a guardian whose very existence has helped shape the story of life in our corner of the universe. As our gentle exploration continues, we'll discover how Jupiter's immense scale compares to other worlds beyond our solar system, and what its massive presence might teach us about the countless other planetary systems scattered throughout the galaxy. As we continue our peaceful journey through Jupiter's immense domain, let's drift towards something that might make you pause in quiet wonder. Jupiter's massive scale becomes even more remarkable when we consider that this giant world is still in many ways, a mystery to us. Despite centuries of observation and multiple spacecraft missions, we're only just beginning to understand the full implications of its enormous size. Deep within Jupiter's massive interior, pressures and temperatures reach conditions that we can barely replicate in our most advanced laboratories on Earth. The hydrogen that makes up most of Jupiter's bulk exists in forms that would seem almost alien to us. Near the surface, it behaves like the gas we know, light and airy. But as you descend deeper into Jupiter's vast interior, the weight of all that material above creates pressures so intense that hydrogen transforms into something extraordinary. About halfway to Jupiter's center, the pressure becomes so immense that hydrogen begins to behave like a liquid metal, conducting electricity in ways that would be impossible under normal conditions. This metallic hydrogen, a substance that exists nowhere else in our solar system in such quantities, is thought to be responsible for Jupiter's incredibly powerful magnetic field. It's a state of matter so exotic that scientists are still working to fully understand its properties. Picture this for a moment. If you could somehow journey into Jupiter's interior, you would pass through layers of atmosphere, then liquid hydrogen, then this strange metallic hydrogen, all under pressures millions of times greater than what we experience at Earth's surface. At the very center, there may be a solid core of rock and ice, perhaps 10 to 20 times the mass of our entire planet, crushed under the weight of all that hydrogen and helium above. This layered structure is a direct result of Jupiter's massive scale. Only a world with Jupiter's enormous gravitational pull could compress hydrogen into these exotic forms. Smaller planets simply don't have the mass necessary to create such extreme conditions in their interiors. In a way, Jupiter is like a natural laboratory, creating states of matter that we're only beginning to explore and understand. The heat generated by these extreme pressures has kept Jupiter warm for billions of years. Unlike Earth, which relies entirely on the sun for its energy, Jupiter glows with its own internal fire. This isn't the nuclear fire of a star, but the steady warmth of gravitational compression, like a cosmic hand slowly squeezing a ball of gas and releasing energy in the process. This internal heat source has profound implications for Jupiter's moons. Europa's subsurface ocean remains liquid partly because of the tidal heating caused by Jupiter's massive gravity, but also because of the infrared radiation that Jupiter itself emits. The giant planet acts like a dim hearth, providing just enough extra warmth to keep water from freezing solid in the cold outer reaches of the solar system. Even more intriguingly, some scientists speculate that Jupiter's internal heat might create conditions suitable for life deep within the planet's atmosphere. In the layers where pressure and temperature are similar to Earth's surface conditions, complex organic chemistry might be possible. While no one expects to find forests floating in Jupiter's clouds, the possibility of microbial life existing in the planet's vast atmospheric ocean remains tantalizingly open. Jupiter's massive scale also creates some of the most spectacular light shows in the solar system. The planet's powerful magnetic field channels charge particles toward its poles, creating auroras that dwarf anything we see on Earth. These Jovian auroras are not just larger and more intense than Earth's northern lights, they're powered by a completely different mechanism. While Earth's auroras are created primarily by particles from the solar wind, Jupiter's auroras are largely powered by particles stripped from the volcanic moon Io. As Io orbits through Jupiter's magnetic field, it leaves behind a trail of sulfur and oxygen ions that eventually spiral down toward Jupiter's poles, creating a constant, brilliant display of lights that would be visible from space even during Jupiter's day. The sheer scale of these auroras is breathtaking. The auroral ovals at Jupiter's poles are larger than Earth itself, glowing rings of light that pulse and dance as particles crash into the planet's upper atmosphere at tremendous speeds. If you could somehow hover above Jupiter's North Pole, you would see a crown of light more magnificent than anything in our terrestrial experience. But Jupiter's influence on light and magnetism extends far beyond its own atmosphere. The planet's massive magnetic field creates a kind of magnetic highway that connects it to its moons. Io, in particular, is electrically connected to Jupiter by what scientists call a flux tube, an invisible pathway of magnetic field lines that carries electrical current between the moon and the planet. This electrical connection is so powerful that it generates radio waves that can be detected by radio telescopes on Earth. Jupiter is actually one of the strongest radio sources in our solar system, broadcasting its presence across interplanetary space with signals generated by the interaction of its massive magnetic field with its volcanic moon. These radio emissions were first detected in the 1950s, long before we had spacecraft to visit Jupiter directly. Astronomers were surprised to discover that this distant giant planet was producing radio waves at all, let alone signals strong enough to be detected across hundreds of millions of miles. It was our first hint that Jupiter's massive scale created phenomena unlike anything we see in the inner solar system. The discovery of Jupiter's radio emissions opened up an entirely new way of studying the planet and its moons. By carefully analyzing these radio signals, scientists can monitor the activity of Io's volcanoes, track changes in Jupiter's magnetic field, and even detect when new moons pass through the planet's magnetosphere. Jupiter's massive presence also affects the very space around it in ways that continue to surprise scientists. The planet's enormous gravitational field doesn't just attract objects toward it, it also shapes the paths of light itself. This gravitational lensing effect is usually too subtle to notice with Jupiter, but it demonstrates a profound truth about massive objects in space. According to Einstein's theory of general relativity, mass warps the fabric of space and time. Jupiter's enormous bulk creates a depression in this cosmic fabric, like a bowling ball placed on a stretched rubber sheet. Light traveling near Jupiter follows the curves of this warped space, bending slightly as it passes the giant planet. While this effect is too small to see with Jupiter from Earth, it becomes important for spacecraft navigation. Mission planners must account for Jupiter's gravitational influence on radio signals traveling between Earth and probes exploring the outer solar system. The planet's massive presence subtly delays these signals, and this delay must be calculated precisely to maintain communication with distant spacecraft. This warping of space and time also affects how we measure distances in the outer solar system. The presence of Jupiter's massive gravity field creates tiny but measurable distortions in the geometry of space around it. These effects are so subtle that they require atomic clocks and laser interferometry to detect, but they provide direct confirmation of Einstein's predictions about how massive objects influence the structure of space itself. Perhaps most remarkably, Jupiter's massive scale may have played a crucial role in the development of life on Earth in ways we're only beginning to understand. The planet's enormous gravitational influence doesn't just protect us from asteroids and comets today. It may have helped establish the very conditions that made life possible billions of years ago. Some scientists propose that Jupiter's gravity helped deliver the right amount of water to the early Earth. Too little water, and our planet would have remained a dry, lifeless rock. Too much water, and the entire surface might have been covered by a global ocean with no dry land for complex life to evolve upon. Jupiter's massive presence may have fine-tuned the delivery of water-bearing comets and asteroids to create just the right conditions for life to emerge and flourish. The giant planet may also have influenced the development of Earth's atmosphere by controlling the bombardment of volatile rich objects from the outer solar system. These impacts delivered not just water, but also the carbon, nitrogen, and other elements essential for the chemistry of life. Jupiter's gravitational shepherding may have ensured that Earth received these vital ingredients in just the right proportions. Even the timing of these deliveries may have been crucial. Jupiter's massive influence on the orbits of small bodies throughout the solar system created periods of heavy bombardment interspersed with quieter epochs. This irregular delivery schedule may have given life on Earth the breathing room it needed to establish itself between periods of catastrophic impacts. As we contemplate Jupiter's role as both protector and provider, we begin to see how the planet's massive scale has woven itself into the very fabric of life's story on Earth. Every breath you take, every drop of water you drink, every organic molecule in your body may owe its presence on Earth to the gravitational influence of this distant giant. This connection between Jupiter's mass and the conditions for life extends beyond our own planet. As we discover more and more exoplanetary systems throughout the galaxy, we're finding that the presence or absence of Jupiter-like worlds seems to correlate with the potential for smaller, Earth-like planets to maintain stable, life-friendly conditions. Star systems with massive planets in Jupiter-like orbits tend to have more orderly arrangements of smaller worlds, while systems without such gravitational anchors often show signs of chaotic planetary migrations and disrupted orbits. Jupiter's massive presence may be a key ingredient in the recipe for stable planetary systems capable of nurturing life. This realization has profound implications for our search for life beyond Earth. As we design new telescopes and develop new techniques for studying distant worlds, we're learning to look not just for Earth-like planets, but for entire planetary systems that include Jupiter-like guardians to protect and stabilize their smaller siblings. Jupiter's massive scale serves as a reminder that in the cosmos, size matters in ways both obvious and subtle. The giant planet's enormous bulk doesn't just make it impressive to look at through a telescope, it makes it a fundamental force in shaping the architecture of planetary systems and the conditions necessary for life to emerge and persist. As our gentle exploration of Jupiter's incredible mass continues, we find ourselves not just marveling at numbers and comparisons, but discovering a deeper truth about our place in the cosmic order. We exist in a solar system where a massive giant stands guard in the outer darkness, its enormous presence quietly ensuring that smaller worlds like Earth can maintain the delicate balance necessary for life to flourish across billions of years. In the vast tapestry of the universe, Jupiter's massive scale represents more than just impressive statistics. It embodies the elegant interplay of forces that transforms cosmic chaos into cosmic order, creating the stable, nurturing environment that has allowed consciousness itself to emerge and contemplate the very forces that made its existence possible. When we consider Jupiter's massive scale in the context of the broader universe, something truly remarkable emerges. This giant world that dominates our solar system suddenly becomes a bridge between the familiar and the exotic, between the worlds we know and the countless others scattered throughout the galaxy like distant lighthouses in the cosmic night. Jupiter's mass places it in a very special category of worlds. It sits right at the boundary between what we call a planet and what astronomers term a brown dwarf. Those curious objects that are too massive to be planets, but not quite massive enough to ignite as stars. If Jupiter were about 13 times more massive than it already is, it would begin fusing deuterium in its core, transforming from a failed star into the smallest possible type of stellar object. This proximity to the stellar threshold makes Jupiter a kind of cosmic stepping stone, helping us understand how matter behaves when it's caught between planetary and stellar existence. In a way, Jupiter represents the upper limit of what a world can be while still remaining, fundamentally, a world rather than a star. But perhaps the most fascinating aspect of Jupiter's mass becomes apparent when we compare it to the thousands of exoplanets we've discovered orbiting other stars. These distant worlds come in a bewildering variety of sizes, compositions, and orbital arrangements. Yet many of them bear striking similarities to our own Jupiter. Hot Jupiters, those massive worlds that orbit incredibly close to their parent stars, often have masses similar to Jupiter but experience surface temperatures hot enough to melt metal. These scorching giants remind us that Jupiter's particular combination of mass and orbital distance isn't just impressive, it's remarkably well suited for creating a stable, life-friendly solar system. Other Jupiter-like worlds orbit at distances similar to our own giant planet, but around stars very different from our Sun. Some circle red dwarf stars that will shine for trillions of years, creating planetary systems with timescales that dwarf the history of our own solar system. Others orbit massive blue stars that burn bright and die young, creating brief but spectacular cosmic environments where Jupiter-mass worlds experience conditions unlike anything in our quiet corner of space. The diversity of these Jupiter analogues tells us something profound about the role that massive worlds play throughout the galaxy. They're not rare cosmic accidents, but common features of planetary systems, suggesting that the processes that created Jupiter's enormous bulk are fundamental to how worlds form around stars. Yet for all this diversity, our Jupiter remains special in its particular combination of characteristics. Its mass is large enough to dominate the outer solar system, but not so large that it disrupts the inner planets. Its distance from the Sun places it in the sweet spot where it can accumulate massive amounts of hydrogen and helium while still allowing rocky worlds to form closer to our star. This delicate balance extends to Jupiter's rotation rate as well. The planet's rapid 10-hour day creates the dynamic atmospheric patterns we see in its cloud bands, but it's not so fast that it would tear the planet apart or create chaotic, unstable weather systems. Jupiter spins at just the right speed to create order from the chaos of its massive atmosphere. The magnetic field generated by Jupiter's rapid rotation and metallic hydrogen core is another example of this cosmic fine-tuning. It's strong enough to create a protective magnetosphere that shields the planet's moons from harmful radiation, yet not so powerful that it would strip away any atmospheres those moons might have. Europa's thin oxygen atmosphere and Ganymede's tenuous water vapor envelope exist because Jupiter's magnetic field is precisely calibrated to protect without overwhelming. This protective quality of Jupiter's massive magnetic field extends far beyond its immediate moon system. The planet's magnetosphere creates a kind of cosmic bubble that deflects high-energy particles from deep space, reducing the radiation environment throughout the outer solar system. Without this magnetic shield, missions to Saturn, Uranus, and Neptune would face much more dangerous radiation environments. The sheer persistence of Jupiter's magnetic field is itself a testament to the planet's massive scale. Earth's magnetic field, generated by our planet's much smaller molten iron core, has reversed polarity many times throughout geological history. Jupiter's magnetic field, powered by the convection of metallic hydrogen in its vast interior, has remained stable for billions of years, providing a constant source of protection for its family of moons. This stability extends to Jupiter's orbit as well. Despite the gravitational perturbations from Saturn and the other outer planets, Jupiter's massive inertia keeps it locked in a remarkably stable path around the Sun. This orbital constancy has been crucial for maintaining the long-term stability of the entire solar system, preventing the kind of chaotic orbital evolution that might have ejected Earth from the habitable zone or sent it spiraling into the Sun. The gravitational resonances that Jupiter maintains with the other outer planets create a kind of cosmic clockwork that has operated with precision for billions of years. Saturn orbits the Sun almost exactly twice for every orbit Jupiter completes, a relationship that helps stabilize both giant planets and prevents them from migrating significantly inward or outward over time. These orbital resonances ripple throughout the solar system, influencing the movements of smaller bodies in subtle but important ways. The asteroid belt structure is largely determined by gravitational resonances with Jupiter, creating gaps where asteroids cannot maintain stable orbits and concentrations where they're protected from Jupiter's disruptive influence. Even the Kuiper belt, that distant collection of icy bodies beyond Neptune's orbit, bears the imprint of Jupiter's massive gravitational influence. The planet's gravity helped shape the distribution of these objects during the early solar system's chaotic youth, when the giant planets may have migrated significantly before settling into their current orbits. This migration, known as the Grand Tack model, suggests that Jupiter may have actually moved inward toward the Sun during its formation before being pulled back outward by gravitational interactions with Saturn. If this model is correct, then Jupiter's massive presence literally sculpted the inner solar system, preventing Mars from growing larger and ensuring that Earth formed in just the right location to become habitable. The implications of this possible migration are staggering. Without Jupiter's inward journey and subsequent retreat, the asteroid belt might have formed into a fifth rocky planet. Mars might have grown to rival Earth in size. The entire architecture of the inner solar system might have been fundamentally different, with consequences we can only begin to imagine for the emergence of life. This dynamic history reminds us that Jupiter's current massive presence is the result of a complex dance of gravitational forces that played out over millions of years during the solar system's youth. The planet we see today, steadily orbiting at its current distance from the Sun, is not where it was born, but where it ended up after a long journey through the evolving solar system. The fact that this journey resulted in a configuration so favorable to life on Earth seems almost miraculous. A slightly different timing of Jupiter's migration, a different mass for the planet, or a different interaction with Saturn might have created a solar system where Earth never formed, or where it formed in a location unsuitable for liquid water and life. Yet, here we are, contemplating Jupiter's massive presence from the surface of a world that owes its very existence to the complex gravitational choreography that this giant planet helped orchestrate billions of years ago. Every sunset we watch, every breath of air we take, every drop of water that sustains us exists because Jupiter's enormous bulk ended up in just the right place at just the right time. This realization transforms our view of Jupiter from a distant curiosity into an intimate part of our own story. The giant planet isn't just a massive world orbiting far from Earth. It's a fundamental component of the cosmic machinery that makes our existence possible. Its gravity doesn't just shape the outer solar system, it shapes the conditions under which life itself can emerge and flourish. As we continue our gentle drift through the implications of Jupiter's incredible scale, we find ourselves not just learning about a distant world, but discovering the hidden connections that bind us to the farthest reaches of our solar system. Jupiter's massive presence whispers to us across the vast emptiness of space, reminding us that we are all part of a single interconnected cosmic family, held together by the invisible threads of gravity and time. In the quiet moments when Jupiter is visible in the night sky, hanging like a bright star above the horizon, we're witnessing more than just reflected sunlight from a distant world. We're seeing a guardian, a shepherd, a cosmic architect whose massive influence has helped create and maintain the delicate balance that allows our small blue planet to remain a haven for life in the vast darkness of space. The story of Jupiter's mass is ultimately the story of our own existence, written in the language of gravity and orbital mechanics, told through the patient accumulation of hydrogen and helium in the cold outer reaches of a young solar system billions of years ago. It's a story that continues to unfold today as Jupiter's massive presence continues to shape the cosmic environment in which we live, breathe, and wonder at the magnificent complexity of the universe that surrounds us. As our exploration of Jupiter's incredible scale draws us deeper into contemplation, we begin to understand that this massive world represents something more than just an impressive collection of gas and ice. It embodies the fundamental principles that govern how matter organizes itself across the cosmos, from the smallest atoms to the largest structures in the universe. Jupiter's mass demonstrates the power of gravity to create order from chaos, to transform a diffuse cloud of particles into a coherent world with its own weather systems, magnetic field, and family of moons. This same process, scaled up across vast reaches of space and time, is responsible for the formation of galaxies, star clusters, and the cosmic web that connects all matter throughout the observable universe. In this sense, Jupiter serves as a kind of cosmic laboratory where we can study the fundamental forces that shape reality itself. Its massive bulk creates conditions of pressure and temperature that reveal how matter behaves under extreme circumstances, providing insights that help us understand not just our own solar system, but the countless other worlds that populate the galaxy. The gentle giant continues its ancient dance around the sun, its massive presence a constant reminder that we live in a universe where size, gravity, and time conspire to create beauty, complexity, and wonder on scales that stretch from the subatomic to the cosmic. And in that dance we find our own place, our own story, our own quiet moment of awe at the magnificent tapestry of existence that Jupiter's incredible mass helps weave across the darkness of space. The true measure of Jupiter's immensity becomes even more profound when we consider its gravitational reach, which extends far beyond the visible disk we see through telescopes. This invisible sphere of influence, known as Jupiter's Hill Sphere, stretches nearly 53 million kilometers from the planet's center. That's roughly 1/3 of the distance from Earth to the Sun, a gravitational domain so vast that it could encompass dozens of Earth-sized worlds with room to spare. Within this enormous sphere, Jupiter reigns supreme. Any object that wanders into this region finds itself inexorably drawn into the planet's gravitational embrace. It's here that Jupiter captures wayward asteroids, transforms them into moons, and orchestrates the complex orbital dances of its extensive satellite system. The Hill Sphere is Jupiter's kingdom, a realm where the giant planet's massive presence overrides even the Sun's gravitational pull. This gravitational sovereignty extends to some of the most fascinating objects in our solar system, the Trojan asteroids. These rocky remnants from the solar system's formation have been trapped in Jupiter's orbit for billions of years, clustering at two gravitationally stable points that lead and follow the planet in its journey around the Sun. There are thousands of these Trojan asteroids, each one a testament to Jupiter's ability to capture and hold objects across vast distances. The leading group of Trojans, known as the Greek Camp, precedes Jupiter by about 60 degrees in its orbit. The trailing group, called the Trojan Camp, follows at the same distance behind. These two asteroid swarms are like cosmic escort fleets, forever bound to Jupiter's massive presence as it sweeps through the outer solar system. They're prisoners of gravity, but gentle prisoners, held in place by the delicate balance between Jupiter's pull and their own orbital motion. What makes these Trojan asteroids particularly remarkable is their stability. Despite the gravitational perturbations from other planets, despite the occasional close encounter with a wandering comet, they've maintained their positions relative to Jupiter for eons. This stability is a direct consequence of Jupiter's enormous mass, which creates gravitational refuges where smaller objects can find sanctuary from the chaotic dynamics of the early solar system. The discovery of Jupiter's Trojans revolutionized our understanding of how gravitational systems work. These stable points, known as Lagrange points, exist in any two-body system where one object is much more massive than the other. But they only become significant repositories for matter when the primary object has sufficient mass to create deep gravitational wells. Jupiter's enormous bulk makes it the perfect host for these cosmic hitchhikers. But Jupiter's gravitational influence extends even beyond its Hill sphere through a phenomenon called the Kozai effect. This subtle gravitational interaction can alter the orbits of distant objects, changing their inclinations and eccentricities over long periods. Even comets in the far reaches of the outer solar system feel Jupiter's influence as they make their long, slow journeys around the Sun. These distant interactions reveal something profound about Jupiter's role in solar system dynamics. The planet doesn't just affect objects in its immediate vicinity, it shapes the orbital evolution of bodies throughout the entire solar system. A comet that formed in the outer reaches billions of years ago may have had its current orbit determined by a close encounter with Jupiter that happened millions of years in the past. This temporal aspect of Jupiter's influence adds another layer to our understanding of its massive scale. The planet's gravitational effects ripple both through space and through time, creating consequences that unfold over geological timescales. A single gravitational encounter with Jupiter can alter an object's trajectory for millions of years, sending it on a completely different path through the solar system. Consider the short-period comets that regularly visit the inner solar system, those spectacular visitors with orbital periods of less than 20 years. Many of these comets owe their current orbits to past encounters with Jupiter. The planet's massive gravity has acted like a cosmic billiard cue, deflecting these icy visitors from their original paths and sending them into the inner solar system where they delight astronomers and sky watchers alike. Jupiter's role as a gravitational sculptor extends to the very architecture of the solar system itself. The planet's massive presence has helped establish what astronomers call the snow line, the distance from the Sun where water ice can remain stable. This invisible boundary, located just beyond Jupiter's orbit, marks the transition between the rocky inner planets and the gas-rich outer worlds. The snow line's position was crucial during the solar system's formation because it determined where different types of planets could form. Inside the snow line, only rocky materials could condense from the solar nebula, leading to the formation of small, dense worlds like Earth and Mars. Beyond the snow line, water ice was available as a building material, allowing the formation of much larger planetary cores that could eventually capture massive atmospheres and become gas giants. Jupiter's own formation near the snow line was no coincidence. The abundance of ice and other volatile materials at that distance provided the raw materials needed to build a core massive enough to trigger runaway gas accretion. Without the snow line's position, Jupiter might never have grown large enough to become the giant we see today. This relationship between Jupiter's mass and the snow line creates a feedback loop that has shaped the entire solar system. Jupiter's gravity helps maintain the snow line's position by preventing the inward migration of ice-rich material from the outer solar system. At the same time, the snow line's existence enabled Jupiter to form in the first place by providing the necessary building materials at just the right distance from the Sun. The precision of this arrangement is striking. If the snow line had been located closer to the Sun, Jupiter might have formed closer to Earth's orbit, potentially preventing the formation of rocky planets altogether. If the snow line had been farther out, Jupiter's core might never have grown massive enough to capture a significant atmosphere, leaving us with a solar system of rocky worlds and no gas giants at all. This delicate balance extends to Jupiter's chemical composition as well. The planet's massive bulk contains a detailed record of the conditions present in the outer solar system during its formation. The ratios of different elements in Jupiter's atmosphere, the isotopic signatures of its constituent gases, even the presence of noble gases like argon and xenon, all provide clues about the environment in which this massive world took shape. Recent measurements by the Juno spacecraft have revealed that Jupiter's atmosphere is more complex than previously thought. The planet contains more water than expected, suggesting that it formed farther from the Sun than its current location. This water abundance supports models of planetary migration, where Jupiter's massive bulk allowed it to wander through the early solar system before settling into its current orbit. The heavy elements in Jupiter's atmosphere also tell a story of cosmic enrichment. Unlike the Sun, which is composed almost entirely of hydrogen and helium left over from the Big Bang, Jupiter contains significant amounts of carbon, nitrogen, oxygen, and other heavy elements forged in the nuclear furnaces of previous generations of stars. These elements were incorporated into Jupiter during its formation, making the planet a kind of cosmic archive of stellar nucleosynthesis. Jupiter's massive scale allows it to retain these heavy elements despite the intense radiation environment in the outer solar system. Smaller worlds would gradually lose their atmospheres to space over billions of years, but Jupiter's enormous gravity holds tight to every molecule. The planet is so massive that its escape velocity, the speed needed for an object to break free of its gravitational pull, exceeds 60 kilometers per second, nearly 6 times faster than Earth's escape velocity. This incredible retention ability means that Jupiter preserves a pristine record of the early solar system's composition. By studying the planet's atmospheric chemistry, scientists can learn about the conditions that existed when the solar system was young, when the planets were still forming from the debris of the original solar nebula. The isotopic ratios in Jupiter's atmosphere are particularly revealing. The planet's deuterium to hydrogen ratio, for example, provides insights into the temperature and density conditions in the solar nebula when Jupiter formed. The abundance of noble gases offers clues about the sources of volatile materials that contributed to the planet's growth. These chemical fingerprints, preserved in Jupiter's massive bulk, extend our understanding of planetary formation far beyond our own solar system. As we discover more exoplanets around other stars, we can use Jupiter as a template for understanding how massive worlds form and evolve in different stellar environments. The preservation of primordial materials in Jupiter's atmosphere also has implications for understanding the origin of life. Many of the organic compounds needed for life, including water, methane, ammonia, and various carbon-bearing molecules, are present in Jupiter's atmosphere. While the planet's extreme conditions preclude complex life as we know it, it serves as a reservoir of the raw materials from which life might emerge elsewhere. Some of these materials may have been delivered to the early Earth through impacts by comets and asteroids perturbed by Jupiter's massive gravity. In this way, Jupiter may have served not just as a protector of Earth from cosmic impacts, but also as a supplier of the very molecules that made life possible on our world. The connection between Jupiter's massive scale and the chemistry of life extends to the planet's moons as well. Europa's subsurface ocean contains more than twice as much water as all of Earth's oceans combined, while Ganymede and Callisto also harbor significant amounts of liquid water beneath their icy surfaces. These hidden oceans exist because Jupiter's massive tidal forces generate enough heat to keep water liquid despite the frigid temperatures in the outer solar system. The tidal heating process works because Jupiter's enormous mass creates powerful gravitational gradients across its moons. As these moons orbit the giant planet, they are stretched and compressed by the changing tidal forces, generating heat through friction in their interiors. This process is so efficient that it can maintain liquid oceans for billions of years, creating potentially habitable environments in the cold outer reaches of the solar system. The discovery of these hidden oceans has revolutionized our thinking about where life might exist in the universe. Before we knew about Europa's ocean, most scientists assumed that life required a planet orbiting in the habitable zone around a star, where liquid water could exist on the surface. Now we know that massive planets like Jupiter can create their own habitable zones through tidal heating, potentially harboring life in places we never thought to look. This realization has profound implications for the search for life beyond our solar system. Gas giant planets are common throughout the galaxy, and many of them likely have moon systems similar to Jupiter's. If tidal heating can maintain liquid water oceans around these distant worlds, then the number of potentially habitable environments in the universe could be far larger than we ever imagined. Jupiter's massive scale thus serves as more than just an impressive statistic or a cosmic curiosity. It represents a fundamental mechanism for creating and maintaining the conditions necessary for life, not just on planets orbiting in traditional habitable zones, but on moons orbiting massive worlds throughout the galaxy. The giant planet's enormous bulk becomes a source of life-giving energy, warming hidden oceans and creating oases of possibility in the cold depths of space. As we continue our gentle drift through the implications of Jupiter's incredible mass, we begin to see how this distant giant connects to the deepest questions about our place in the universe. Its massive presence shapes not just the dynamics of our solar system, but our understanding of how life might emerge and persist in the countless other planetary systems scattered throughout the cosmos. In the quiet darkness of space, Jupiter continues its ancient journey around the Sun, its massive bulk creating ripples of influence that extend far beyond what the eye can see. These invisible threads of gravity weave through the solar system like a cosmic web, connecting the giant planet to every other object in its domain, from the smallest grain of dust to the most distant comet. And in that web of connections, we find ourselves intimately linked to this massive world, our own existence shaped by forces that began billions of years ago when hydrogen and helium first began to collapse under their own gravity in the cold, outer reaches of a young and chaotic solar system. Jupiter's incredible mass is not just a number or a measurement, it's a fundamental part of the story of how worlds are born, how life emerges, and how consciousness itself comes to contemplate the magnificent forces that brought it into being. When we think about Jupiter's immense scale, it's tempting to focus on the numbers, the comparisons, the sheer overwhelming bigness of it all. But perhaps the most profound aspect of Jupiter's mass is how it whispers to us about the delicate balance that governs everything we know. This massive world, for all its enormity, exists in a state of perfect equilibrium that has persisted for billions of years. Consider the elegant dance between Jupiter's rapid rotation and its gravitational self-compression. The planet spins so quickly that it completes a full rotation in less than 10 hours, creating centrifugal forces that would tear apart a less massive world. But Jupiter's enormous gravity holds everything together, creating a dynamic tension between the outward force of rotation and the inward pull of its own mass. This balance manifests in Jupiter's slightly flattened shape, but it goes much deeper than surface geometry. Deep within the planet's interior, the same forces that created its metallic hydrogen core continue to operate, generating the powerful magnetic field that protects not just Jupiter itself, but its entire family of moons from the harsh radiation environment of space. The equilibrium extends to Jupiter's energy budget as well. The planet radiates more heat into space than it receives from the Sun, a consequence of its gradual gravitational contraction. As Jupiter slowly shrinks under its own immense weight, it converts gravitational potential energy into thermal energy, maintaining an internal heat source that has glowed steadily for over 4 billion years. This internal warmth creates a fascinating paradox. Jupiter is simultaneously cooling down and warming up, losing heat to space while generating new heat through compression. It's a process so gradual that the planet shrinks by only about 2 centimeters per year, yet so persistent that it has fundamentally shaped the evolution of the outer solar system. The heat flowing from Jupiter's interior drives the complex atmospheric dynamics that create the planet's distinctive banded appearance. These bands aren't just pretty patterns in the clouds. They're manifestations of massive convection currents powered by the planet's internal energy. Hot material rises from the deep interior, cools as it reaches the upper atmosphere, and then sinks back down in a continuous cycle that has been operating for eons. These atmospheric rivers flow at speeds that would dwarf Earth's most powerful jet streams, yet they maintain their structure with remarkable stability. The Great Red Spot, that famous hurricane larger than our entire planet, has been raging for centuries precisely because Jupiter's massive scale provides the energy and stability needed to sustain such enormous weather systems. But Jupiter's atmospheric dynamics reveal something even more remarkable about its massive scale. The planet's weather systems are so large that they operate on timescales completely different from anything we experience on Earth. A storm on Jupiter might take decades to evolve, centuries to dissipate, creating a kind of atmospheric geology where weather patterns become as permanent as mountain ranges. This temporal dimension of Jupiter's mass extends to its gravitational relationships as well. The orbital resonances that lock Jupiter's largest moons into their precise dance around the planet took millions of years to establish. These gravitational synchronizations, where moons orbit with periods related by simple mathematical ratios, represent a kind of cosmic clockwork that Jupiter's massive presence has gradually constructed over geological time. The process continues today as Jupiter's gravity slowly shepherds its moons into increasingly stable configurations. Io's volcanic activity, Europa's subsurface ocean, Ganymede's magnetic field, and Callisto's ancient cratered surface all exist in their current states because of the long-term gravitational influence of their massive parent planet. These tidal relationships demonstrate how Jupiter's mass creates not just immediate effects, but cascading consequences that unfold over vast spans of time. The heat that keeps Europa's ocean liquid today was generated by gravitational kneading that began billions of years ago and continues with each orbit around Jupiter. The planet's massive presence doesn't just hold its moons in orbit, it actively shapes their internal evolution. This shaping power extends beyond Jupiter's immediate family to influence the entire outer solar system. The planet's massive gravity has been slowly reorganizing the orbits of asteroids, comets, and other small bodies for billions of years, creating a complex architecture of stable and unstable regions throughout the solar system. The Kirkwood gaps in the asteroid belt, those empty spaces where asteroids cannot maintain stable orbits, are direct consequences of Jupiter's massive gravitational influence. Objects that wander into these regions find their orbits gradually altered by Jupiter's pull until they're either ejected from the solar system or sent careening into the inner planets. This gravitational sculpting process continues today as Jupiter's massive presence slowly but inexorably alters the paths of countless small objects throughout the solar system. Each gravitational encounter, however brief, leaves its mark on the object's trajectory, creating a complex web of cause and effect that links Jupiter's massive bulk to the motion of bodies throughout the entire solar system. The planet's influence on comets is particularly dramatic. These visitors from the distant reaches of the solar system often have their orbits completely transformed by close encounters with Jupiter's massive gravity. A comet that originally took thousands of years to complete one orbit around the Sun might find itself redirected into a path that brings it back to the inner solar system every few years. These orbital transformations create the spectacular comet displays that occasionally grace our skies. Many of the most famous comets in history, from Halley's Comet to Comet Shoemaker-Levy 9, owe their current orbits to past gravitational encounters with Jupiter's massive bulk. The planet acts like a cosmic traffic director, routing these icy visitors through the inner solar system where they can delight and inspire observers on Earth. But perhaps the most profound way that Jupiter's mass affects our understanding of the cosmos is through its role as a gravitational laboratory. The extreme conditions created by the planet's enormous bulk allow us to study physics in regimes that are impossible to replicate on Earth. The metallic hydrogen that exists deep within Jupiter's interior, for example, is a form of matter that can only exist under the tremendous pressures created by the planet's massive gravity. This exotic state of matter may hold clues to fundamental questions about how atoms behave under extreme conditions, information that could revolutionize our understanding of materials science and condensed matter physics. Jupiter's powerful magnetic field, generated by the motion of this metallic hydrogen, creates a natural laboratory for studying plasma physics on scales that dwarf anything we can create artificially. The interactions between charged particles and magnetic fields in Jupiter's magnetosphere provide insights into processes that occur throughout the universe, from the solar wind to the behavior of matter around black holes. The planet's atmospheric dynamics offer similar opportunities to study fluid mechanics and thermodynamics on scales impossible to achieve in terrestrial laboratories. The massive convection currents in Jupiter's atmosphere, driven by the planet's internal heat and rapid rotation, create natural experiments in turbulence and energy transport that inform our understanding of everything from weather prediction to stellar evolution. These natural experiments become even more valuable when we consider that Jupiter's massive scale makes it a bridge between planetary and stellar physics. The planet's interior conditions, while extreme by terrestrial standards, are relatively mild compared to those found in stars. By studying Jupiter, we can explore the transition region between planetary and stellar physics, gaining insights into how matter behaves across this crucial boundary. This bridging role extends to Jupiter's formation history as well. The planet's massive bulk preserves a record of the conditions that existed in the outer solar system during its formation, including information about the temperature, pressure, and chemical composition of the original solar nebula. By studying Jupiter's interior structure and atmospheric composition, scientists can learn about the environment in which all the planets formed. The isotopic ratios preserved in Jupiter's atmosphere, for example, provide a kind of chemical fingerprint of the early solar system. These ratios tell us about the sources of material that contributed to Jupiter's formation, the temperature conditions that existed when the planet was growing, and the processes that distributed heavy elements throughout the solar nebula. This chemical archaeology becomes particularly important when we consider Jupiter's role in delivering materials to the inner solar system. The planet's massive gravity has been deflecting comets and asteroids toward Earth for billions of years, potentially delivering not just water but also complex organic molecules that may have contributed to the origin of life on our planet. The carbon, nitrogen, sulfur, and phosphorus compounds found in Jupiter's atmosphere represent a reservoir of the basic building blocks of life. While these molecules exist in forms and under conditions that preclude life as we know it on Jupiter itself, they demonstrate that the raw materials for biology are abundant in the outer solar system. Jupiter's massive presence may thus have played a crucial role not just in protecting Earth from excessive bombardment, but in supplying our planet with the chemical ingredients necessary for life to emerge and evolve. The planet's gravitational influence has been quietly nurturing the conditions for life in the inner solar system for billions of years. This nurturing role extends to Jupiter's continuing influence on Earth's environment. The planet's massive gravity helps stabilize the orbits of potentially hazardous asteroids and comets, reducing the frequency of catastrophic impacts that could disrupt the biosphere. While impacts still occur, they would be far more common without Jupiter's protective presence. The planet's gravitational shepherding also helps maintain the asteroid belt in a relatively stable configuration. Without Jupiter's massive influence, the asteroid belt might either collapse into the inner solar system, creating a hazardous environment for life on Earth, or disperse into the outer solar system, depriving the inner planets of the materials needed for ongoing geological processes. This protective function demonstrates how Jupiter's massive scale creates stability not just within its own moon system, but throughout the entire solar system. The planet's enormous bulk acts like a gravitational anchor, providing a stable reference point around which the complex dynamics of planetary motion can organize themselves. The mathematical precision of these gravitational relationships is truly remarkable. The orbital resonances between Jupiter and Saturn, between Jupiter and the asteroid belt, between Jupiter and its moons, all represent solutions to what mathematicians call the many-body problem, one of the most challenging areas of celestial mechanics. These resonant relationships exist because Jupiter's massive presence creates deep gravitational wells in the fabric of space-time, stable configurations where smaller bodies can find refuge from the chaotic gravitational influences of multiple massive objects. The planet's enormous mass essentially provides the gravitational muscle needed to maintain these delicate dynamical balances over geological time. As we drift toward the end of our gentle exploration of Jupiter's incredible mass, we begin to see how this single number, 318 times the mass of Earth, ripples outward through space and time to influence virtually every aspect of our solar system's structure and evolution. Jupiter's massive presence is woven into the very fabric of our cosmic neighborhood, a gravitational thread that connects the formation of planets billions of years ago to the possibility of life existing on distant moons today. The giant planet's enormous bulk reminds us that in the cosmos, everything is connected through the invisible but inexorable influence of gravity. From the tiniest grain of dust swept up by Jupiter's magnetosphere to the grandest orbital resonances that govern the motion of worlds, the planet's massive presence touches everything within its vast sphere of influence. And that sphere of influence, it turns out, extends much farther than we might imagine. Jupiter's gravitational effects ripple through the solar system like waves in a cosmic pond, creating patterns of order and stability that have persisted for billions of years and will continue for billions more. In this grand cosmic symphony, Jupiter's massive presence provides the deep, resonant bass note that gives structure and stability to the entire composition. Without this fundamental tone, the delicate harmonies of planetary motion, the subtle rhythms of orbital resonance, and the complex counterpoint of gravitational interaction might dissolve into chaos. But with Jupiter's massive anchor firmly in place, our solar system continues its ancient dance, a gravitational ballet choreographed by forces so vast and persistent that they transform the cold emptiness of space into a stage for the emergence of worlds, the evolution of life, and the quiet contemplation of consciousness itself. As Jupiter continues its patient journey around the Sun, its massive presence serves as a reminder that we live in a universe where size matters not just for its own sake, but for the profound influence it exerts on everything around it. The giant planet's incredible mass is more than just an impressive statistic. It's a fundamental force that has shaped the very conditions under which we exist, think, and wonder at the magnificent complexity of the cosmos that surrounds us. In the vast theatre of our solar system, Jupiter's massive presence creates what we might call gravitational poetry, a subtle artistry written in the language of orbital mechanics and celestial harmony. This poetry unfolds not in verses and stanzas, but in the graceful arcs of comets returning home, in the synchronized dances of distant moons, and in the quiet protection offered to smaller worlds like our own Earth. Consider for a moment the sheer patience of Jupiter's influence. The planet has been gently nudging, guiding, and organizing the solar system for over 4 billion years. Never rushing, never forcing, simply applying its massive gravitational presence with the kind of persistence that only cosmic timescales can accommodate. It's a reminder that the most profound changes often happen slowly, accumulating over eons until their effects become undeniable. This patient influence extends to some of the most beautiful phenomena in our night sky. The Perseid meteor shower, those brilliant streaks of light that grace our summer evenings, exists partly because of Jupiter's ancient gravitational encounters with the comet Swift-Tuttle. The planet's massive pull helped establish the comet's current orbit, ensuring that Earth passes through its debris trail every August, creating a celestial fireworks display that has delighted observers for centuries. Jupiter's gravitational artistry doesn't stop with meteor showers. The planet's massive presence has helped create what astronomers call the Jupiter family of comets, a collection of short-period comets whose orbits have been sculpted by repeated encounters with the giant planet's gravity. These comets, with orbital periods typically less than 20 years, provide regular opportunities for scientists to study pristine materials from the outer solar system, materials that may preserve clues about the conditions present when our solar system was young. The regularity of these comet visits speaks to something profound about Jupiter's role as a cosmic timekeeper. The planet's massive gravity doesn't just influence objects randomly, it creates predictable patterns, reliable cycles that allow us to anticipate celestial events years or even decades in advance. This predictability emerges from the mathematical precision with which gravity operates, transforming the apparent chaos of space into an ordered, knowable system. But Jupiter's influence on time extends beyond the scheduling of comet visits. The planet's massive presence helps regulate the very pace at which our solar system evolves. Without Jupiter's gravitational anchor, the orbits of the other planets might drift chaotically over time, creating an unstable system where worlds could migrate into new orbits or even be ejected from the solar system entirely. This stabilizing influence has been crucial for life on Earth. Our planet's orbit has remained remarkably stable for billions of years, staying within the narrow range of distances from the Sun that allow liquid water to exist on the surface. While many factors contribute to this stability, Jupiter's massive gravitational presence provides a crucial stabilizing influence that helps maintain Earth's climate-friendly orbit over geological time. The planet's protective role extends to Earth's axial tilt as well. Our planet's 23.5-degree tilt gives us our seasons, but this tilt could vary dramatically over time without the stabilizing influence of our large moon. And the moon itself may owe its existence partly to Jupiter's influence during the early solar system's chaotic youth, when the giant planet's gravity may have helped clear debris that could have disrupted the formation of the Earth-Moon system. These interconnected relationships reveal something beautiful about Jupiter's massive scale. The planet doesn't exist in isolation, but as part of a complex web of gravitational relationships that connect every object in the solar system. Jupiter's enormous bulk provides the gravitational foundation that allows these relationships to develop and persist, creating a cosmic ecosystem where each component influences and is influenced by all the others. This ecosystem includes not just planets and moons, but the countless smaller objects that populate the space between worlds. Jupiter's massive gravity helps maintain the asteroid belt in a configuration that provides a valuable scientific resource while minimizing the threat to inner planets. The planet's influence has prevented the asteroid belt from either collapsing inward or dispersing outward, maintaining it as a kind of cosmic museum where we can study the leftover building blocks of planet formation. The Trojan asteroids that share Jupiter's orbit represent another facet of this cosmic ecosystem. These rocky remnants have been trapped at gravitationally stable points for billions of years, creating two asteroid swarms that precede and follow Jupiter in its journey around the Sun. These objects exist in a state of perfect gravitational balance, held in place by the complex interplay between Jupiter's massive pull, the Sun's gravity, and their own orbital motion. Recent space missions have begun to explore these Trojan asteroids, revealing them to be time capsules from the early solar system. Their compositions and structures provide insights into the conditions that existed when the planets were forming, materials preserved in the cold outer reaches of the solar system by Jupiter's gravitational influence. In studying these ancient objects, we're essentially examining fossils from the solar system's youth, preserved by the same massive forces that continue to shape our cosmic neighborhood today. Jupiter's role as a cosmic archaeologist extends to its capture and preservation of materials from throughout the solar system's history. The planet's enormous gravity acts like a kind of gravitational net, capturing objects that might otherwise be lost to interstellar space. Some of Jupiter's smaller, irregular moons may be captured asteroids or comets, objects that wandered too close to the giant planet and became permanent members of its extended family. These captured objects carry with them the chemical signatures of their origins, providing samples of materials from different regions of the solar system. By studying the compositions of Jupiter's diverse moon system, scientists can learn about the distribution of materials throughout the early solar system and how that distribution has evolved over time. The preservation aspect of Jupiter's massive influence becomes particularly important when we consider the planet's role in maintaining the chemical inventory of the solar system. Smaller worlds gradually lose their atmospheres to space over geological time, but Jupiter's enormous gravity allows it to retain even the lightest gases indefinitely. This makes the planet a reservoir of primordial materials, a cosmic library where the original composition of the solar nebula is preserved for future study. The heavy water, noble gases, and organic compounds in Jupiter's atmosphere represent samples of the raw materials from which all the planets formed. These materials exist in Jupiter's atmosphere in ratios that reflect the conditions present in the outer solar system billions of years ago, providing a kind of chemical fingerprint of our cosmic origins. This preservational role extends to Jupiter's influence on the delivery of materials to other worlds as well. The planet's massive gravity has been redirecting comets and asteroids throughout the solar system's history, sometimes sending them on collision courses with inner planets. While these impacts can be catastrophic, they also serve as delivery mechanisms for water, organic compounds, and other materials essential for planetary evolution. Earth's oceans may contain water delivered by comets deflected toward our planet by Jupiter's gravitational influence. The carbon-based molecules essential for life may have arrived through similar processes. In this sense, Jupiter's massive presence has been actively contributing to the chemical evolution of the inner solar system for billions of years, helping to create the conditions necessary for life to emerge and flourish. The timing of these deliveries may have been as important as their content. Jupiter's gravitational influence creates periods of increased bombardment, alternating with quieter epochs, giving emerging life on Earth the breathing room it needed to establish itself between major impact events. This irregular but predictable pattern of delivery and quiescence may have been crucial for life's ability to gain a foothold on our planet. As we consider Jupiter's massive influence on the flow of materials through time, we begin to appreciate how the planet's enormous bulk creates not just spatial organization, but temporal structure as well. The giant planet's gravity operates like a cosmic clockwork, creating rhythms and cycles that persist across billions of years and influence everything from the delivery of life's building blocks to the timing of mass extinction events. These temporal patterns remind us that Jupiter's massive scale affects not just the space around it, but time itself. The planet's gravitational influence creates a kind of temporal architecture in the solar system, establishing cycles and periodicities that connect past, present, and future in ways that continue to unfold across cosmic time. In contemplating Jupiter's incredible mass and its far-reaching consequences, we find ourselves marveling not just at numbers and statistics, but at the elegant complexity of gravitational relationships that transform a collection of gas, dust, and ice into a functioning cosmic ecosystem. Jupiter's enormous bulk serves as the gravitational heart of this system, pumping energy and organization throughout the outer solar system with each orbit around the Sun. The planet's massive presence reminds us that in the cosmos, influence and importance aren't always proportional to visibility or proximity. This distant giant, barely visible as a point of light in our night sky, exerts profound influence over conditions here on Earth and throughout the solar system. Its gravitational reach extends across billions of miles and billions of years, connecting the formation of worlds in the ancient past to the possibility of life existing on distant moons today. As Jupiter continues its stately procession around the Sun, its massive bulk carries with it the accumulated gravitational wisdom of 4.5 billion years of orbital experience. Each circuit adds another chapter to the ongoing story of how massive objects shape the cosmos around them, how gravity transforms chaos into order, and how the patient accumulation of matter in the cold outer reaches of space can influence the emergence of consciousness itself in the warm inner regions of a planetary system. The giant planet's incredible mass stands as testament to the power of gravity to create not just individual worlds, but entire cosmic communities bound together by invisible threads of mutual influence. In Jupiter's massive embrace, we see reflected the fundamental truth that everything in the universe is connected, that no world exists in isolation, and that the forces that shape the largest structures in the cosmos are the same forces that make possible the delicate chemistry of life itself. And perhaps most remarkably, this massive world with its enormous influence remains accessible to us, visible to the naked eye on any clear night when it graces our sky. In that tiny point of reflected sunlight, we witness the presence of a cosmic giant whose mass has helped write the very story of our existence, a patient guardian whose gravitational embrace has been quietly nurturing the conditions for life in our corner of the universe for longer than life itself has existed on Earth. When we truly grasp Jupiter's immense scale, we begin to understand that we're not just looking at a planet, but at a cosmic force that has been quietly orchestrating the symphony of our solar system for over 4 billion years. Every breath you take, every drop of water that sustains you, every stable orbit that keeps Earth in the habitable zone bears the subtle influence of this distant giant's enormous gravitational embrace. Jupiter's massive presence whispers across the void with a patience that spans geological ages, its gravitational voice speaking in the language of orbital mechanics and celestial harmony. The planet's enormous bulk creates what we might think of as a gravitational melody, one that plays out across millions of years in movements too slow for human perception, but profound enough to shape the very architecture of worlds. This melody manifests in the gentle spirals of galaxies, in the predictable return of comets, in the synchronized dances of moons locked in orbital resonance. It's written in the gaps between asteroid families, in the delivery routes that brought water to Earth, in the protective barriers that shield our inner solar system from the chaos of deep space. The remarkable thing about Jupiter's mass is how it transforms mere size into influence, bulk into beauty, gravity into grace. The planet doesn't dominate through force or violence, but through the persistent application of natural law, the steady accumulation of gravitational effects that compound over cosmic time like interest in some celestial bank account. Consider the poetry of Jupiter's relationship with time itself. While we experience time as a river flowing from past to future, Jupiter experiences it as an ocean of gravitational potential, where past encounters with comets create future meteor showers, where ancient orbital adjustments continue to influence the stability of worlds billions of years later. The planet's massive scale allows it to serve as a kind of temporal anchor, a gravitational lighthouse whose influence extends not just through space, but through time, connecting the chaotic birth of our solar system to the ordered cosmos we inhabit today. Each orbit around the Sun adds another layer to this temporal sculpture, another verse to the gravitational poem that Jupiter has been composing since the dawn of our planetary neighborhood. In Jupiter's enormous mass, we find reflected one of the universe's most beautiful truths, that patience and persistence, applied consistently over vast spans of time, can transform chaos into order, randomness into rhythm, emptiness into abundance. The giant planet stands as a monument to the power of gravity to create not just individual worlds, but entire communities of worlds, bound together by invisible threads of mutual gravitational influence. This influence ripples outward like waves on a cosmic pond, touching everything within its reach with the gentle but inexorable force of its enormous bulk. From the tiniest grain of dust swept up in its magnetosphere to the grandest orbital resonances that govern the motion of distant worlds, Jupiter's massive presence shapes the very fabric of our cosmic neighborhood. And perhaps most remarkably, this shaping continues today as you listen to these words, as Jupiter continues its ancient journey around the Sun. The planet's enormous gravity is still capturing wayward asteroids, still deflecting dangerous comets, still maintaining the delicate gravitational balances that keep our solar system stable and life-friendly. The giant planet's mass serves as a reminder that in the cosmos, the most profound influences often operate invisibly, patiently, without fanfare or announcement. Like a master conductor guiding a cosmic orchestra, Jupiter's enormous gravitational presence coordinates the movements of countless worlds and smaller bodies, creating harmony from what might otherwise be chaos. In the quiet moments when Jupiter hangs in our night sky like a bright jewel against the darkness, we're witnessing more than just reflected sunlight from a distant world. We're seeing the physical manifestation of forces so vast and fundamental that they've helped create the very conditions under which consciousness itself could emerge to contemplate the universe. Jupiter's incredible mass reminds us that we live in a cosmos where size matters not just for its own sake, but for the profound and lasting influence it can exert across space and time. The planet's enormous bulk has been writing the story of our solar system for over 4 billion years, and that story continues to unfold today with each orbit, each gravitational encounter, each subtle adjustment to the cosmic clockwork that governs our celestial home. As we drift toward the end of our gentle exploration of Jupiter's magnificent scale, we're left with a sense of quiet awe at the elegant complexity of the universe we inhabit. This massive world, so distant yet so influential, so enormous yet so precisely calibrated to create rather than destroy, stands as testament to the beautiful mathematics that underlies all of existence. In Jupiter's patient journey around the Sun, in its steady gravitational embrace of its family of moons, in its protective influence over our inner solar system, we see reflected the very best of what the cosmos has to offer. Order emerging from chaos, stability arising from motion, and the quiet persistence of natural forces working together to create something far more beautiful and complex than the sum of their individual parts. The giant planet's incredible mass teaches us that true influence comes not from drama or spectacle, but from consistency, patience, and the steady application of fundamental forces across vast spans of time. Jupiter has been quietly shaping our cosmic neighborhood for longer than life has existed on Earth, and it will continue this gentle work long after our Sun has grown old and dim. In contemplating Jupiter's enormous scale, we find ourselves humbled by the realization that we are part of something far grander than ourselves. Citizens of a solar system whose very architecture has been shaped by forces so massive and persistent that they transform the apparent emptiness of space into a stage for the emergence of worlds, the evolution of life, and the quiet contemplation of consciousness itself. And so, as Jupiter continues its stately dance around our sun, its massive presence serves as both anchor and inspiration, a reminder that in this vast and sometimes lonely universe, we are held in the gentle but firm gravitational embrace of a cosmic giant whose enormous heart beats with the steady rhythm of worlds in motion, moons in orbit, and the eternal dance of matter and energy that makes all existence possible. Tonight, when you step outside and see Jupiter shining in the darkness, remember that you're looking at more than just a planet. You're witnessing the physical embodiment of forces that have shaped not just our solar system, but our very existence. In that tiny point of light lies the mass of more than 300 Earths, a gravitational influence that reaches across billions of miles, and a story of cosmic architecture that connects the birth of worlds to the emergence of life itself. Sweet dreams, fellow traveler. May your rest be as peaceful as Jupiter's eternal orbit, and may you wake refreshed and ready to explore more of the magnificent mysteries that surround us in this beautiful, ordered, gravitationally bound cosmos we call home. As we approach the gentle conclusion of our cosmic journey, let's take one final peaceful moment to consider what Jupiter's incredible mass truly means in the grand tapestry of existence. This massive world, hanging like a distant beacon in our night sky, carries within its enormous bulk a story that stretches back to the very origins of everything we know and love. Jupiter's mass isn't just an impressive number or a cosmic curiosity. It's a fundamental thread in the fabric of reality itself, woven so deeply into the structure of our solar system that removing it would unravel the entire cosmic neighborhood we call home. Every stable orbit, every protective barrier, every delivery of life-giving materials to the inner planets bears the invisible signature of this distant giant's gravitational embrace. The planet's enormous scale serves as a bridge between the familiar and the infinite, helping us understand that the same forces that keep our feet planted on Earth also govern the motion of worlds separated by hundreds of millions of miles. In Jupiter's patient orbit, we see reflected the beautiful mathematics that underlies all of existence, the elegant equations that transform emptiness into order and chaos into cosmic harmony. Perhaps most remarkably, Jupiter's massive influence continues to unfold around us every moment, as subtle and persistent as the passage of time itself. While you've been listening to this gentle exploration, the giant planet has been quietly maintaining the gravitational relationships that keep our solar system stable, deflecting potential threats and nurturing the hidden oceans of distant moons where life might even now be stirring in the darkness. This ongoing work happens without fanfare or announcement, a cosmic service performed with the same steady patience that has characterized Jupiter's influence for over 4 billion years. The planet asks for nothing in return for its protective presence, content to continue its ancient dance around the sun while its enormous gravity writes poetry in the language of orbital mechanics. In Jupiter's incredible mass, we find a reminder that the most profound influences in our lives often operate invisibly, shaping our world in ways we rarely pause to consider. Just as the giant planet's gravitational embrace extends across the solar system, touching everything within its reach with gentle but inexorable force, so too do the quiet influences in our own lives create ripples that extend far beyond what we can see. The planet's enormous bulk stands as testament to the power of persistence, to the way that consistent forces applied patiently over vast spans of time can create something far more beautiful and complex than any single moment might suggest. Jupiter has been quietly nurturing the conditions for life in our corner of the universe since before Earth had oceans, before our sun had settled into its steady shine, before time itself had meaning for any conscious observer. And now, as our peaceful exploration draws to its close, we find ourselves changed by the journey. We've traveled not just through space, but through understanding, discovering that this distant giant is intimately connected to our own existence in ways both subtle and profound. Jupiter's massive presence has helped create the very conditions under which we can contemplate the cosmos, wonder at its beauty, and find our place within its vast embrace. The giant planet continues its stately procession even now, carrying within its enormous bulk the accumulated wisdom of billions of years of gravitational experience. Each moment adds another page to the ongoing story of how massive objects shape the universe around them, how patience and persistence can transform the apparent chaos of space into the ordered beauty of our solar system. As you settle into sleep tonight, perhaps you'll carry with you a new appreciation for the invisible threads that connect us to the cosmos. Jupiter's incredible mass reminds us that we are not alone in the darkness, but part of a vast community of worlds held together by forces as old as time itself and as enduring as the stars. In that gentle realization, we find not just knowledge but comfort, not just facts but wonder. The universe reveals itself to be not a cold and empty void, but a warm and nurturing home where massive guardians like Jupiter stand watch in the darkness, their enormous presence ensuring that smaller worlds like our own can flourish in the light of a stable star. Sweet dreams, gentle explorer. May your rest be as peaceful as Jupiter's eternal orbit, and may you wake tomorrow with eyes open to the magnificent forces that surround us, support us, and remind us every day that we are part of something far grander and more beautiful than we could ever imagine alone. As we approach the gentle conclusion of our cosmic journey, let's take one final peaceful moment to consider what Jupiter's incredible mass truly means in the grand tapestry of existence. This massive world, hanging like a distant beacon in our night sky, carries within its enormous bulk a story that stretches back to the very origins of everything we know and love. Jupiter's mass isn't just an impressive number or a cosmic curiosity. It's a fundamental thread in the fabric of reality itself, woven so deeply into the structure of our solar system that removing it would unravel the entire cosmic neighborhood we call home. Every stable orbit, every protective barrier, every delivery of life-giving materials to the inner planets bears the invisible signature of this distant giant's gravitational embrace. The planet's enormous scale serves as a bridge between the familiar and the infinite, helping us understand that the same forces that keep our feet planted on Earth also govern the motion of worlds separated by hundreds of millions of miles. In Jupiter's patient orbit, we see reflected the beautiful mathematics that underlies all of existence, the elegant equations that transform emptiness into order and chaos into cosmic harmony. Perhaps most remarkably, Jupiter's massive influence continues to unfold around us every moment, as subtle and persistent as the passage of time itself. While you've been listening to this gentle exploration, the giant planet has been quietly maintaining the gravitational relationships that keep our solar system stable, deflecting potential threats and nurturing the hidden oceans of distant moons where life might even now be stirring in the darkness. In Jupiter's incredible mass, we find a reminder that the most profound influences in our lives often operate invisibly, shaping our world in ways we rarely pause to consider. The planet's enormous bulk stands as testament to the power of persistence, to the way that consistent forces, applied patiently over vast spans of time, can create something far more beautiful and complex than any single moment might suggest. And now, as our peaceful exploration draws to its close, we find ourselves changed by the journey. We've discovered that this distant giant is intimately connected to our own existence in ways both subtle and profound. Jupiter's massive presence has helped create the very conditions under which we can contemplate the cosmos, wonder at its beauty, and find our place within its vast embrace. As you settle into sleep tonight, perhaps you'll carry with you a new appreciation for the invisible threads that connect us to the cosmos. Jupiter's incredible mass reminds us that we are not alone in the darkness, but part of a vast community of worlds held together by forces as old as time itself and as enduring as the stars. Sweet dreams, gentle explorer. May your rest be as peaceful as Jupiter's eternal orbit, and may you wake tomorrow with eyes open to the magnificent forces that surround us, support us, and remind us every day that we are part of something far grander and more beautiful than we could ever imagine alone. Boring Science Channel was the host today. See you in the next one. Boring Science Channel was the host today. See you in the next one.